Hello and welcome back to my YouTube channel. This is going to be a continuation on how to load vector layers from different data sources. In part 1 of this particular series, we took a look at shapefiles and geopackage. In this video, we'll try and see if we can cover the rest of the data sources. So the next one we'll be looking at is DXF, Drawing Exchange Format. DXF, which stands for Drawing Exchange Format, is primarily used for storing drawing data like designs from CAD application, which is computer-aided design. Let's get down to breaking down the code. This line, just like the other lines that we've looked at so far, is the path to the DXF file on my computer. So it might be different in your case. Again, this part of the code is pretty standard. We have my D drive, my GIS folder, and then we have the name of my DXF file. This part of the code is also similar to the geopackage. We have the pipe symbol, and then we have layer name equal to entities, which specifies the layer within our DXF file we want to load. And we also have the pipe symbol again, and the geometry type points 2D, which states that we are interested in 2.5D point geometry, have an X, Y, and a Z, which is the elevation value. This line we create a QGIS vector layer using the path of our file, and then we give our layer a name, and then we provide the provider QGIS should use to read the file. We check if our layer is valid. If it is valid, we print the name of the layer. So we'll print the DXF file, just like we did for the others. If it isn't, then we'll print can't load layer. So that is it for loading DXF files. Now let's take a look at GPX files. GPX stands for GPS Exchange Format. It is a format used to represent and store the GPS data like tracks, routes, and waypoints. The minimum requirement for a GPX data are the latitude and longitude coordinates. In addition, GPS files optionally stores location properties including time, elevation, and geode height as tags. So with that out of the way, let's get into the code. So this is the code for loading a GPX file. By now, I hope that you can see a pattern with all the layers and data sources that we have learned about so far. We have the path to the file name, and then we have the pipe symbol. So with file formats that can store multiple layers in them, like geopackage, like DXF, and like GPX, with those ones, usually the pipe operator is very necessary to specify which layer within the file format that we want to display. So in this case, we have a layer name called route points, which is a layer within our GPX file format or GPS data source. We create a vector layer, we input the path to the file, the base map, and then we also specify the provider. The provider so far has been the same. So that is it for loading GPX. The next file we'll be looking at is CSV. CSV stands for comma separated value. CSV files are plain text files that store tabular data. In GIS, they are mostly used to store coordinate values alongside other data. And the reason why they are called CSV is because each value or each column is separated by a comma mostly. It can be separated by tab and space, but mostly it's just comma. So that's where it gets its name, comma separated values. Okay, so let's get into the code. So what you can see here is the code for loading CSV files. As you can see, it's a little bit different from what we have been doing so far. So instead of the usual path to our file, here we prefix the path name with file, and then we have 3 back strokes right before we have the path to our CSV file, and then our query parameters. So we first have our file, and then the usual path name, right? and then we have our query parameters. Right, so unlike the others we've done so far, this can be separated into 3 separate entities that have come together to form the path to our CSV. Okay, so what we'll be focusing on will be the latter part, that will be our query parameters. So we are used to the pipe operator with the query parameter, that is the question mark. The question mark in the context of programming and especially within URLs often signifies the beginning of a query string. Right, that's why I keep referring to it as a query parameter, a query string. So a query string is like a part of a URL that contains data, usually in the form of parameters or key value pairs, to be passed to the web-based application. So let's break down our query string piece by piece. So the first one we'll be looking at will be the X field equal to longitude and Y field equal to latitude. So this specifies columns in our CSV file which holds the X, which is the longitude, and then the Y, which is the latitude values. Okay, so you have to know your CSV file. You have to know how you have named your columns. So whichever column that holds the X value, you put the name here. So in this case, we are using longitude because that's the longitude in our CSV file, right? But in your file, the longitude, you might name it long or something else. Whichever it is, you specify that there, and then you do the same for the latitude. Okay, and then the last one, which is the CRS, is optional. It is very preferable if you specify that. So what that does is that it states the coordinate reference system for the data. So usually, in this case, we are using the 4326, which is a common code for WGS 84, often used in GPS systems, and then like Google Maps and those maps that you see on most websites. This line is just the same as what we have observed, except the only difference is that the provider is different, right? In the previous example, the provider was OGR. In this, for CSV, the provider is delimited text. That is the provider in which QGIS will be using to read our CSV file. The next file we'll be looking at is WFS. WSF, which stands for Web Feature Service. It's a standard protocol for sending geospatial data over the internet. So instead of downloading and storing data files on your local machine, you might want to request files that has been stored on the internet. So those sort of services are what we call WFS, Web Feature Services. Let's get into breaking down the code for WFS data source. So this is a code for loading WSF data source. It's also different from the other ones. So as we talked about, WSF files are straight up URLs, right? So there is no path to it on my system. They are hosted on the internet. So you have to actually use actual URL. So this particular WSF service is supposed to be a feature of active mines in US. This whole portion of the code is targeting the URL for the active mines. Then we come to our query strings, just like we learned with the CSV. So the SRS name is equivalent to CRS in the CSV files, which sets our coordinate system, our coordinate reference system. The type name identifies the specific layer or the feature type that we want from our CSV. So here, the type that we are looking for are the mine plants. That's why the type name is the mine plant. Another portion, which is the request equal to get feature. This tells the WFS service you want to retrieve or get the features of our active mines features. So the service confirms the type of web service being requested, which in this case is a WFS service. As I said, there are different types of services that are offered. WSF is one of them. So after that, Again, we create our vector layer by including the paths to our vector data source. We specify the name, and then also the provider is plain WFS. That way, sort of prompts QGIS what provider it should use to read our WSF data source. So if all is well and done, we check for the validity of our layer. If it is, we print the name. If it isn't, it prints can't load. So when you run the code, we'll get the name of our data source. So now we can just run the code to see the results. And as you can see, we have the name of our layer, which is WSF layer, with the same name here. And that's a wrap on loading vector layers from multiple data sources in PyQGIS. If you found this helpful, don't forget to like, share, and subscribe. And as always, happy learning. Bye.